Hello there, dear traveler, and welcome to the Sleepy Scientist, that quiet corner of the cosmos, crafted just for you. It's a place where curiosity gently meets calm, and where the soft cradle of science will slowly rock you into a peaceful slumber. Tonight, we are about to embark on a celestial journey together, one that is far more profound and ancient than any voyage you might imagine. Before you close your eyes, before you allow your thoughts to drift among the stars, I'd love to know something very special. Where in the world are you listening from tonight? And what time is it for you? Right now, in this very moment. Please, let me know gently in the comments below. I'm always utterly amazed by this wonderful connection we share. How so many of us, from vastly different corners of our globe, can be drifting together under the same cosmic glow. If you find tonight's voyage to be a source of calm and wonder, if it brings you even a small measure of peace, please consider giving this video a gentle like, and perhaps you might softly click that subscribe button, so you don't miss our next stargazing session. Every small gesture from you helps more sleepy minds find their way here, to this quiet harbor where they can rest. Now, tonight's story is a truly beautiful and immensely grand tale of creation. It's about how galaxies, those sprawling, luminous cities of stars, are born from the profound darkness and the delicate dust of the early universe. I sincerely hope it's not so interesting that it keeps you wide awake, but if it does, well, that's all right too. At least, before the aroma of your morning coffee fills the air, you'll know just a little bit more, and marvel a little more, about the early universe's magnificent beginnings. So, for now, please, settle in, make yourself utterly comfortable, let your shoulders softly drop, releasing any tension they might hold. Breathe slowly, deeply, gently. You are about to drift through 13.8 billion years of cosmic history. There's absolutely no rush. The stars, those patient watchers, will wait for you. Let us begin. 13,800,000,000 years ago, the very beginning of our universe was a singularity almost impossible to describe in ordinary language. It wasn't merely small, not in the way you describe a studio apartment with no windows. It was unimaginably compact, hotter by millions of degrees than the core of any star, and denser, perhaps, than a physicist's calendar during Nobel season. And then, in a moment that truly defies our full comprehension, it began. It wasn't precisely an explosion, despite the name, the Big Bang. Rather than a thunderous burst of shrapnel, was more akin to a rapid, remarkably graceful swelling, space itself, expanding outward in every single direction, at a speed faster than light, like a balloon being inflated with a leaf blower set to cosmic mode, at an astonishing rate. There wasn't debris flying through empty space, because space was the debris, and it was actively making itself as it went, ever expanding. In those first, fleeting microseconds, the universe was a seething, turbulent broth of fundamental particles. Quarks jostled vigorously with gluons. Photons zipped around like restless, energetic toddlers, darting this way and that, and gravity, ever the patient, silent sculptor, quietly began making its notes, observing, taking stock. It was a chaotic, blindingly hot, and extremely uncomfortable place. Definitely not a serene spot for stargazing, nor a cozy corner for marshmallow roasting just yet. But this early universe, for all its intense mayhem and disarray, was brimming with infinite potential. Hydrogen and helium, the two simplest and lightest elements, began to form like cosmic Lego bricks, gently snapping together from the charged chaos. These humble, unassuming atoms would, over eons, go on to build absolutely everything we know. Stars, planets, people, even the sleepy pet lizards curled up in your home. And, of course, the grand subject of our story tonight, galaxies. Approximately 380,000 years after the Big Bang, a mere blink in cosmic terms. Really, on the vast timescale of the universe, something truly beautiful and profoundly significant happened. The universe had cooled sufficiently, reaching a critical temperature where the charged atomic nuclei could finally capture the free-floating electrons. They combined, forming the very first neutral atoms. In that singular moment, light, which had previously been ricocheting around like a trapped firefly in a jar in the early, dense universe, unable to travel freely, was suddenly set free. It was able to stream through the previously opaque cosmic fog, traveling without hindrance. This pivotal moment, known as recombination, created the cosmic microwave background CMB, a soft, gentle afterglow of the Big Bang's initial fiery outburst. It still hums quietly through the universe today, permeating every corner. If your eyes possess the ability to see microwaves, the entire sky, in every direction you looked, would glow with the light of that ancient fire. It would be an indescribable, gentle, yet persistent luminosity. However, despite this pervasive glow, there were no stars, no galaxies yet, not in the way we know them. The universe at this point was still a dark, expanding cloud of gas and immense potential. If you could have drifted through it, then you would have seen nothing but subtle ripples, tiny, almost imperceptible irregularities in the otherwise smooth distribution of matter. Yet, these seemingly insignificant ripples were everything. They were the faint whispers of quantum fluctuations from the universe's earliest moments, stretched across the vast cosmos by the astonishing expansion of inflation. Some regions were just ever so slightly denser than others, barely a difference. Truly, almost negligible. But gravity, the universe's oldest observer, noticed, and gravity does not forget. Over the slow march of time, those slightly denser pockets of hydrogen and helium gas began to pull in more and more material, slowly, gently, gathering like cosmic dew, forming delicate patterns on an invisible spiderweb. These nascent clumps, the very seeds of future galaxies, were utterly invisible to the naked eye, if eyes had existed then, but they were already setting the grand stage for all the dazzling cosmic drama yet to come. It's a bit strange to think of the universe as quiet, but in a profound way, this era truly was. No light from stars, no glowing galaxies, just the faint murmur of matter ever so slowly falling into itself. It was a time of deep stillness before the storm, a long, deep breath in before the universe finally exhaled starlight. And yet, even now, with all our advanced telescopes and complex equations, we are still meticulously piecing together how it all unfolded. How did these minute, almost imperceptible fluctuations eventually lead to the sprawling grandeur of spiral galaxies? Why did some parts of the universe become bustling, vibrant hubs of stars, while others remained vast, dark, empty voids? The answers are intricately written across the cosmos, within every glowing nebula and every ancient star cluster. We just have to keep listening, keep observing, and so the universe continued to grow. Dark matter, the unseen, invisible framework of reality, began to tug and shape the forming structure with its subtle influence. Hydrogen pulled into long, intricate filaments, gravity whispered, and the cosmos, slowly, obediently, responded. Soon, the very first stars would flare into life, ending the profound darkness. But for now, the stage was meticulously set. The universe was no longer just expanding, it was beginning to become the structured, life-filled existence we know today. The stars had not yet arrived. The galaxies still slept, and for a few 100 million years, the universe remained cloaked in what we now refer to as the cosmic dark ages. Despite the ominous name, conveying dark ages, there were no knights or castles here, no dragons either, unless you count the kind made of vast, primordial clouds of plasma and hydrogen. This was darkness in its purest sense, a universe full of matter, yet not yet illuminated by light. After the Big Bang's brilliant opening act and the soft, dissipating glow of the cosmic microwave background, things settled into a profound hush. Neutral hydrogen gas filled space like a vast, invisible fog. There were no stars to shine through it, no galaxies to twinkle in the distant reaches. The universe had gone dim, not because it lacked energy, but because it hadn't yet figured out how to turn on its lights. Imagine floating through this time, adrift in an infinite, expanding sea of cool hydrogen and helium. The occasional electron might drift by, like a lazy jellyfish, slow and unhurried. There's gravity, pulling ever so gently on the gas, forming clouds here and there. But everything moves at a glacial pace, unhurried and deliberate. Not that time meant much in this stage of the universe. No clocks to tick, no days to count, no sunrises to mark the passage of hours. Just the slow, patient accumulation of mass in a universe not yet in a hurry. Yet, something extraordinary was quietly unfolding in this shadowy silence. The groundwork for everything we know was being meticulously laid. You see, during inflation, that lightning-fast expansion right after the Big Bang, tiny quantum fluctuations were impossibly stretched across the expanse of space. These little wiggles in density didn't seem like much to look at initially, but over vast stretches of time, gravity took notice. Wherever matter was even a tiny bit denser, it began to draw more of itself in. Over hundreds of millions of years, These subtle ripples grew into intricate tendrils and dense knots, what we now call the cosmic web. You can picture the universe as a vast, delicate sponge, or perhaps a three-dimensional spiderweb strung together by invisible filaments of dark matter and ordinary gas. These filaments are precisely where galaxies would eventually form, pulled into place by the persistent, unseen hand of gravity. The empty spaces in between them are the voids, giant, lonely stretches of near-nothingness where almost no stars will ever shine. At the silent heart of it all was a quiet partner, dark matter. It doesn't glow, it doesn't reflect light, and it doesn't interact with light at all, which famously makes it incredibly hard to study, and, let's be honest, somewhat bad at parties. But dark matter was absolutely essential. Its profound gravitational influence shaped the very scaffolding of the cosmos, pulling ordinary matter, the hydrogen and helium gas, into place like the hidden, indispensable frame beneath a grand painting. Without dark matter, the universe might have stayed a foggy, undifferentiated cloud forever, never coalescing into the structures we see today. Now, if you're still awake, and if you are, I truly admire your dedication. You might be wondering, why did it take so long for the first stars to appear? Well, building a star isn't as easy as throwing gas into a blender and flipping the sun switch. Hydrogen had to fall into dense enough pockets for gravity to truly take over, relentlessly compressing it until temperatures inside soared to millions of degrees. Only then could fusion, that nuclear dance that lights up a star, truly begin. But the early universe wasn't in a rush. It allowed gravity to work at its own unhurried pace, coaxing the gas into denser and denser clouds, gently but persistently, slowly, patiently. These clouds collapsed under their own immense weight. Somewhere, deep within one of those dense knots of matter, the very first spark would ignite, a single point of light in an ocean of profound dark. And when that happened, almost certainly unnoticed, unceremoniously, a star was born, the first light since the Big Bang, shining once more upon the cosmos. These were no ordinary stars, known as population 3 stars. They were unlike anything we see today, enormous, incredibly unstable, and unbelievably hot. They formed in the purest conditions the universe has ever known. There were no heavy elements then, no carbon, no oxygen, no iron, just hydrogen, helium, and a tiny bit of lithium, all remnants from the Big Bang. This pristine composition made these stars burn hotter and faster than the ones we're familiar with now. Some may have been hundreds of times more massive than our Sun, living short, furious lives before collapsing into black holes or exploding in brilliant, cataclysmic supernovae. If you were floating nearby, though, let's be honest, you'd be very, very crispy. You'd see these first stars lighting up their surroundings like roaring bonfires in a vast, silent cosmic forest. One by one, their powerful light pierced the ancient fog of neutral hydrogen that had filled the universe since its very beginning. Slowly, gradually, the profound darkness began to lift. This period is called cosmic reionization. And while it sounds like something a sci-fi villain might attempt with a ray gun, it was a peaceful, albeit dramatic, process. The potent ultraviolet light from those newborn stars began stripping electrons from the neutral hydrogen around them, ionizing it and making the universe transparent once again. It was as though someone had cracked open the shutters of a vast cosmic greenhouse and let the light flood in. From our perspective, billions of years later, we cannot see these first stars directly. They were too brief in their existence, too distant, and their light too faint to be observed with our current tools. But their fingerprints are everywhere. They utterly transformed the universe from a cold, dark state to a warm, glowing existence. They seeded the cosmos with the first heavy elements, the very building blocks of everything more complicated than hydrogen, including you, me, and the cup of tea you might be sipping right now. In a profound way, these stars were the universe's first artists, sketching the initial outlines of galaxies on the blank canvas of space. But galaxies still hadn't fully formed, not quite. These early stars were often scattered in small clusters, bound together by gravity, but not yet forming the grand, swirling cities of stars we see in the night sky today. These were more like cosmic villages, proto-galaxies, perhaps, cautiously testing the waters of structure and cohesion. Yet, the ingredients were steadily coming together. As these massive stars ended their lives in violent supernovae, they blasted heavier elements into the surrounding gas clouds. Those enriched clouds cooled more efficiently, collapsed faster, and formed stars with greater ease. The next generation of stars, population 2, began to appear, a bit smaller, a bit more stable, and already more familiar to us. And thus, the great cosmic cycle began. Gravity pulls in gas. Stars are born. They shine, live their lives, die, and scatter their enriched contents, carbon, oxygen, iron, into the interstellar medium, enriching the galaxy for the next generation of stars. Each generation builds upon the ashes of the last, layering complexity like stardust sediment. You might wonder, how do we know all this happened if we've never seen these ancient stars with our own eyes? The answer is hidden in patterns of light, like ghostly fingerprints left on the cosmic window pane. By studying the oldest galaxies we can observe the chemical signatures found in ancient stars, and the faint, pervasive glow of the cosmic microwave background. Astronomers can piece together the universe's childhood in astonishing detail. It's a bit like reconstructing the history of a vast forest by meticulously examining its oldest trees, analyzing its soil composition, and discerning the prevailing direction of the wind. The clues are subtle, but they are undoubtedly there. And recently, we've begun to catch tantalizing glimpses, with advanced telescopes like the James Webb Space Telescope. We are finally starting to see some of the earliest galaxies taking shape, small, chaotic, glowing clumps of stars from just a few 100 million years after the Big Bang. We are, in essence, peering directly into the cosmic nursery where the first light bloomed. It's truly humbling, isn't it? These stars lived and died before our solar system was even a distant dream. Their light traveled across space for billions of years, past colliding galaxies, past wandering black holes, past the growing Milky Way, until it landed softly on the mirror of a telescope pointed at the sky. And now, that ancient light rests in your mind, in the quiet of your evening, as you gently drift towards sleep. The universe, once dark and profoundly quiet, had finally lit its first lanterns. The deepest night had ended, and the glorious age of galaxies was about to begin. The universe was glowing now, not brilliantly, not with a blinding intensity, but more like the very first subtle hint of dawn on a cold morning. The stars had finally arrived, their light gently unraveling the pervasive fog, slowly warming the profound silence, but they were scattered, isolated, flickering across the dark like distant campfires with no cities, no roads, just lonely pockets of light suspended in the vast void. But gravity, that silent sculptor, had other plans. Those scattered stars weren't just floating randomly. They were being drawn together by invisible threads, pulled by an unseen force. Everywhere you looked, or would have looked if you'd had a way to see in ultraviolet and the infinite patience of a cosmic being, small clumps of stars were converging. Gravity was quietly threading them into larger, more complex structures. The villages were steadily becoming towns, and these towns, in turn, would become cities, and these nascent cities, these proto-galaxies, were the first rough drafts of what we now call galaxies. It didn't happen neatly. There were no precise blueprints, no cosmic engineers marking out spiral arms with rulers. It was messy. Clumps collided, merged, ripped each other apart in gravitational dances, and then merged again. The early universe was a rough neighborhood, chaotic and dynamic. Gas clouds crashed into each other, compressing violently and igniting, often triggering dramatic bursts of star formation, what astronomers romantically call starbursts. Some early galaxies formed quickly, growing fat on nearby gas and greedily gobbling up their smaller neighbors. Others stalled, stranded in quiet corners of space like cosmic wallflowers, seemingly content in their solitude. At this early stage, galaxies didn't look like the elegant spirals or massive ellipticals we see in glossy telescope images today. They were irregular, profoundly chaotic, unrefined, more like amorphous space blobs than the symmetrical beauties you might imagine. And yet, even in their chaos, they were growing. Slowly, gradually, their shapes began to stabilize, nudged by the persistent hand of gravity and sculpted by their surrounding environments. Much of this early architectural development was influenced by a structure on an even larger scale. The cosmic web. You can picture it like a vast, three-dimensional lace of matter, intricately woven across the entire universe. Dense knots, where filaments of dark matter intersected, became the gravitational hubs, regions where galaxies would cluster together like seeds finding the richest, most fertile soil. Long tendrils stretched between them, pulling galaxies along invisible rails of gravity, and in between these intricate threads lay vast voids, eerie, silent expanses where few, if any, galaxies would ever form. It's in these dense intersections that proto-galaxies had the most to gain, and, paradoxically, the most to fear. When you have a lot of gas and a lot of gravity concentrated in one place, things tend to get a little dramatic. Galaxies would crash into one another. A slow-motion dance that could span hundreds of millions of years. These weren't violent collisions in the way you might expect, with stars smashing into each other. Stars themselves are so incredibly far apart that even in a full-blown galactic collision, the chance of two individual stars actually hitting each other is vanishingly small. It's more like watching two fog banks slowly pass through each other. Only this fog is made of billions of stars, vast clouds of gas, dust, and dark matter, all swirling in immense gravitational fields. But while individual stars may largely avoid direct collisions, the galaxies themselves do not emerge unchanged. When two galaxies meet, their immense gravity pulls and stretches them, distorting their shapes into long, flowing tendrils of stars. These are called tidal tails, and they can span hundreds of thousands of light years across. They look like glowing ribbons, slowly unraveling into space, each one a luminous trail of stars flung outward by the powerful gravitational encounter. Gas clouds, on the other hand, are not so lucky. When they collide, they do so with gusto, compressing, heating up, and often triggering a dramatic, widespread burst of new star formation. These so-called starburst galaxies can produce stars at rates dozens or even hundreds of times faster than usual. It's a cosmic baby boom, sparked by the chaos of gravitational upheaval. Some of the most beautiful and chaotic galaxies we've observed are caught mid-collision. The antennae galaxies, for instance, to spirals in the intense process of merging, show long, curling arms of stars and brilliant regions of new star formation. They're a stunning snapshot of what happens when galaxies refuse to mind their personal space. And eventually, after eons of interaction, the two galaxies will settle into one larger, unified entity. That final product often isn't a spiral anymore. Spiral structures are delicate, too easily disrupted by major gravitational interactions. After a major merger, the result is usually a large, elliptical galaxy. The orderly orbits of stars are randomized, and the gas, much of it used up in the starburst or flung out into intergalactic space, is no longer plentiful enough to form beautiful new spiral arms. This is how many of the largest galaxies in the universe came to be, not from peaceful, gradual accumulation, but from slow motion, majestic crash, like cities built by overlapping tectonic plates. But this isn't just ancient history. The Milky Way is not a passive observer in all this cosmic dance. It has its own collisions to reckon with right now. Even as you're listening, our galaxy is in the slow, ongoing process of merging with several smaller dwarf galaxies. The Sagittarius dwarf galaxy, for instance, is being slowly pulled apart and absorbed, its stars now tracing ghostly, elongated loops through the Milky Way's outer halo. Other small galaxies are on similar paths, being digested, restructured, and folded into our own grand spiral. And then there's Andromeda, our nearest large neighbor. The Andromeda Galaxy is on a direct collision course with the Milky Way. They're separated by approximately 2.5 million light-years, but moving toward each other at about 110 kilometers per second. That might sound incredibly fast, but in galactic terms, It's a slow and graceful approach. The actual collision won't happen for another 4 billion years or so. But when it does, the result will be spectacular. What will happen to us then? Surprisingly little, at least on the scale of our solar system. Again, stars are so incredibly far apart that direct collisions are profoundly unlikely. But the night sky, oh, it will change. Over millions of years, Andromeda will grow larger and brighter, eventually dominating our view of the night sky. The two galaxies will slowly twist around each other, merge, and settle into a new shape, most likely a colossal elliptical galaxy. Astronomers have even lovingly nicknamed the future merger Milkomeda. Yes, really, scientific naming has its moments of whimsy, doesn't it? What's truly astonishing is that we can discern all of this from our vantage point inside the galaxy, thanks to radio telescopes, infrared observations, and an immense amount of clever mathematics. We've been able to map the spiral arms, trace the star populations, and even simulate the galaxy's formation and its ultimate fate. It's like piecing together a jigsaw puzzle from the inside and suddenly realizing the picture is far, far bigger than you ever imagined. And through it all, our tiny star, the Sun, just keeps quietly orbiting. It takes the Sun about 225 million years to make one complete lap around the center of the Milky Way. That means we've only made about 20 trips around the galactic center since the Sun first formed. For reference, the last time we were in this precise galactic neighborhood, the dinosaurs were just beginning to roam the Earth. Galactic years, it turns out, are not measured in birthdays, but in vast, sweeping epochs. So, here we are, spinning quietly in one of the galaxy's spiral arms, a pale blue dot circling an unremarkable yellow star, wrapped in the soft, ancient light of a billion suns. Every single molecule in your body, every atom, was forged in stars that lived and died long, long ago, possibly even in galaxies that were later folded into our own. You are, quite literally, part of the Milky Way story, a moving, breathing fragment of galactic history. You are made of stardust, listening to starlight. The galaxy isn't just out there. You carry it within you, in every fiber of your being. If galaxies are the great, sprawling cities of the cosmos, then what built them? Who, or what, laid their invisible foundations, kept their stars spinning perfectly in place, and ensured they didn't simply drift apart like dandelion seeds scattering in the wind? As it turns out, three unlikely architects have been quietly at work since the very beginning. They are gravity, dark matter, and black holes. Not exactly a charming trio. Perhaps none of them glow or sing or get invited to birthday parties. But without them, the universe would be a very empty, very formless place indeed. Let's begin with gravity, the oldest and most familiar force of the bunch. Gravity is the universe's great gatherer. It doesn't make a fuss. It doesn't shout. It simply pulls. It always has. It always will. In the early universe, when everything was expanding outward from the Big Bang, gravity was the fundamental reason things began to clump together. It took those tiny ripples in the density of space, the faintest of wrinkles in the fabric of spacetime, and began to amplify them, gently drawing gas and dark matter together until stars and galaxies could eventually form. It's slow, it's patient, and it never, ever stops working. But here's the curious thing. Gravity, while utterly relentless, isn't particularly strong. It's actually the weakest of the four fundamental forces in physics. If you drop a paperclip, gravity will pull it to the floor. Hold a small magnet above it, and suddenly the paperclip defies gravity with ease. That tiny magnetic field effortlessly wins against an entire planet's massive gravitational pull. So why, then, does gravity so profoundly shape the cosmos? Because its effects always accumulate. It never cancels itself out, unlike electric or magnetic forces, which can have positive and negative charges. The more mass you have, the more gravity you get. And in the unimaginable vastness of space, where there are no friction brakes or air resistance to slow things down, gravity's quiet, persistent pull simply adds up, over eons, into an unimaginably powerful force. But even with gravity's immense help, there remained a profound mystery. Something was clearly missing when astronomers looked at galaxies. And I mean really looked, carefully measuring how fast their outer stars were spinning. They found something truly strange. The stars farthest from the galactic center were moving far, far too fast. According to the visible mass of the galaxy, all the stars, gas, and dust we could see, those outer stars should have been flung off into space like glitter from a rapidly spinning wheel. But they weren't. They were staying put, loyal, orderly, and incredibly stable. This was a significant problem. Unless there was more mass than we could see. A lot more mass. Enter dark matter, a substance we cannot see, cannot touch, cannot smell, and yet one we are almost certainly convinced exists, because its gravitational fingerprints are unmistakably all over the universe. Dark matter doesn't interact with light. It doesn't glow. It doesn't reflect. And it doesn't absorb light at all. But it absolutely exerts gravity. And there's quite a bit of it. About 5 times more dark matter than normal. Visible matter by mass. That means for every visible star or gas cloud in a galaxy, there's a much larger, invisible halo of dark matter holding everything together, exerting its immense pull. Imagine a galaxy as a glowing, ethereal jellyfish swimming within a giant, invisible bubble. That bubble, the dark matter halo, is precisely what keeps the jellyfish from drifting apart. Without dark matter, galaxies as we know them simply couldn't exist. They wouldn't have formed in the first place. And if they somehow had, they certainly wouldn't stay together. Stars would fly off in all directions. And the beautiful spiral arms we admire so much would never survive their chaotic dance. So far, no one knows exactly what dark matter is. There are plenty of intriguing theories, exotic particles, supersymmetric partners, even ideas involving extra dimensions, but none have been definitively confirmed. Still, its profound effects are undeniable, like the wind on the ocean. We don't need to see it directly to know it's powerfully there. Now, as if galaxies weren't already full of enough secrets, we come to the last of the trio, black holes. And not just any black holes, but supermassive black holes. These cosmic monsters sit at the very centers of nearly every large galaxy we've studied, including our own Milky Way. They range in size from millions to billions of times the mass of our Sun. And while they have the reputation of being destructive, they're more accurately described as galactic administrators, quiet, mysterious, and immensely influential. We used to think supermassive black holes were just passive passengers, cosmic anomalies that happen to form in the center of galaxies. But over the past few decades, we've realized they're more like co-authors of a galaxy's intricate story. Their growth seems intrinsically tied to the development of the galaxy around them. When they feed, devouring gas and dust that falls into their gravitational maw, they release enormous amounts of energy, often more than the galaxy's stars combined. This energy can powerfully blow away the gas needed to form new stars, effectively halting or significantly slowing star formation for millions of years. In other words, black holes don't just sit there like cosmic drains. They actively regulate growth. They profoundly shape the fate of galaxies. This process, called feedback, is still being meticulously studied. But it's clear that supermassive black holes can influence their environments on colossal scales. Jets of plasma, streaming from their vicinity, can stretch for thousands of light years, sculpting the interstellar medium and altering the flow of material across an entire galaxy. It's a bit ironic, isn't it? The darkest things in the universe, the ones that swallow light and defy our direct gaze, are also the very ones that hold it all together. Dark matter, gravity, black holes, they are the unsung, silent architects of everything. And here we are, orbiting a star within a spiral galaxy, nestled within a vast dark matter halo, circling a supermassive black hole we'll never directly meet. Every step we take, every breath we draw, every moment of our existence happens in a universe held together by these invisible hands. So the next time you gaze up at the stars, remember this profound truth: the beauty you see is only half the story. The rest, the invisible scaffolding, the silent, pervasive forces, the quiet, persistent gravity pulling it all together, is still there, not shining, not speaking, but building, always building. Galaxies may look serene in photographs, graceful spirals, glowing halos, delicate dust lanes, but make no mistake, the universe is not a quiet place. Out there, in the profound vastness, galaxies are constantly moving, drifting, orbiting, pulled by gravity like dancers in a never-ending waltz. And occasionally, those dancers get a little too close, their arms entangle, their paths cross, and they collide, not with a bang, not with a sudden, violent explosion, but with a slow, spectacular ballet that gracefully unfolds over hundreds of millions, even billions of years. Yes, galaxies crash into each other, but before you imagine stars exploding and planets smashing like marbles, take a breath. The reality is far more poetic. Despite their immense size, galaxies are mostly empty space. Stars are space so incredibly far apart that even in a full-blown galactic collision, The chance of two individual stars actually hitting each other is vanishingly small. It's truly like watching two enormous fog banks slowly pass through each other. Only this fog is made of stars, vast clouds of gas, dust, and dark matter, all swirling in immense, powerful gravitational fields. But while individual stars may largely avoid direct collisions, the galaxies themselves do not emerge unchanged. When two galaxies meet, their immense gravity pulls and stretches them, distorting their shapes into long, flowing tendrils of stars. These are called tidal tails, and they can span hundreds of thousands of light years across. They look like glowing ribbons, slowly unraveling into space, each one a luminous trail of stars flung outward by the encounter. Gas clouds, on the other hand, are not so lucky. When they collide, they do so with gusto, compressing, heating up dramatically, and often triggering a massive, widespread burst of new star formation. These so-called starburst galaxies can produce stars at rates dozens or even hundreds of times faster than usual. It's truly a cosmic baby boom, directly sparked by the chaos and pressure of gravitational upheaval. Some of the most beautiful and profoundly chaotic galaxies we've observed are caught mid-collision. The antennae galaxies, for instance, are two spirals in the intense process of merging, vividly showing long, curling arms of stars and brilliant, active regions of new star formation. They're a stunning, dynamic snapshot of what happens when galaxies refuse to mind their personal space. And eventually, after eons of interaction, the two galaxies will coalesce and settle into one larger, unified entity. That final product often isn't a spiral anymore. Spiral structures are delicate, too easily disrupted by major gravitational interactions. After a major merger, the result is usually a large, often featureless, elliptical galaxy. The orderly, disk-like orbits of stars are randomized, and the gas, much of it used up in the intense starburst or flung out into intergalactic space, is no longer plentiful enough to form beautiful new spiral arms. This is precisely how many of the largest, most massive galaxies in the universe came to be, not from peaceful, gradual accumulation, but from slow motion, majestic crash, like grand, ancient cities built by overlapping tectonic plates, each collision adding to their immense scale. But this isn't just ancient history, observed only in the distant past. The Milky Way is not a passive observer in all this cosmic drama. It has its own collisions to reckon with, right here and right now. Even as you're listening to my voice, our galaxy is in the slow, ongoing process of merging with several smaller dwarf galaxies. The Sagittarius dwarf galaxy, for example, is being slowly pulled apart and absorbed, its stars now tracing ghostly, elongated loops through the Milky Way's outer halo. Other small galaxies are on similar paths, being gently digested, restructured, and folded into our own grand spiral. And then there's Andromeda, our nearest large galactic neighbor. The Andromeda Galaxy is on a direct collision course with the Milky Way. They're currently separated by approximately 2.5 million light-years, but moving toward each other at about 110 kilometers per second. That might sound incredibly fast to us, but in galactic terms, It's a slow and remarkably graceful approach. The actual full merger won't happen for another 4 billion years or so, giving us plenty of time to get some sleep. But when it does, the result will be truly spectacular. What will happen to us then, when this grand cosmic dance reaches its crescendo? Surprisingly little, at least on the intimate scale of our solar system. Once again, individual stars are spaced so incredibly far apart that direct collisions between them are profoundly unlikely. But the night sky, for observers on Earth, will transform completely and dramatically. Over millions of years, the Andromeda Galaxy will grow steadily larger and brighter in our sky, eventually dominating the view with its immense, approaching presence. The two galaxies will slowly twist around each other, gracefully merge, and ultimately settle into a new, single galactic entity, most likely a colossal elliptical galaxy. Astronomers have even lovingly, and quite whimsically, nicknamed this future merger Mulcomeda. Yes, really, scientific naming, it seems, sometimes has its delightful moments of whimsy. What's truly astonishing, and perhaps a little mind-boggling, is that we can tell all of this from our distinct vantage points inside our own galaxy, thanks to the marvels of radio telescopes, sophisticated infrared observations, and an immense amount of clever mathematical modeling. We've been able to map the intricate spiral arms, trace the vast populations of stars, and even simulate the Milky Way's majestic formation process and its ultimate, long-term fate. It's like painstakingly piecing together a colossal jigsaw puzzle from the inside, only to realize, with a gasp of wonder, that the picture you're creating is far, far grander than you ever could have imagined. And through all of this cosmic ballet, our tiny, unassuming star, the Sun, just keeps quietly orbiting. It takes our Sun about 225 million years to complete one full lap around the center of the Milky Way. That means, remarkably, we've only made about 20 trips around the galactic core since the Sun first formed. For a humbling reference, the last time our solar system was in this precise galactic neighborhood, the dinosaurs were just beginning to roam the Earth. Galactic years, it turns out, are not measured in simple birthdays, but in vast, sweeping epochs of cosmic time. So, here we are, spinning quietly and comfortably in one of the galaxy's majestic spiral arms, a pale blue dot serenely circling an unremarkable yellow star, wrapped in the soft, ancient light of a billion suns. Every single molecule in your body, every intricate atom, was forged in the fiery hearts of stars that lived and died long, long ago, possibly even in galaxies that were later gracefully folded into our own. You are, in the most profound and literal sense, a living, breathing part of the Milky Way story, a moving, evolving fragment of galactic history. You are woven from the very fabric of star stuff. Listening to the gentle echo of starlight, the galaxy isn't just out there, a distant spectacle. You carry its story, its essence, within you, in every cell of your being. To gaze into space is, in a very real and profound sense, to gaze into time. It's one of the quietest, most astonishing facts about the universe. Every star you see twinkling in the night sky, every galaxy captured by a powerful telescope, is not showing you how it looks now, in this very instant, but rather how it looked then, in its distant past. Light, for all its remarkable, incredible speed, still takes time to travel, and space is vast, unimaginably vast, very, very vast. So when we look up at the stars, we are quite literally time traveling. Take the sun, for example. The warm, golden light touching your face during a late afternoon walk left the surface of the sun about 8 minutes ago. That starlight is already 8 minutes old by the time it arrives on Earth. You never truly see the sun as it is in the present moment. You see it as it was. Move beyond our cozy solar system, and the time delay grows exponentially. The light from Alpha Centauri, the nearest star system to us, is over 4 years old when it reaches our eyes, and the soft, ancient glow of the Andromeda Galaxy, that's truly ancient light. It began its arduous journey toward us more than 2.5 million years ago, long before the first humans walked the earth, long before written language emerged, long before the invention of the wheel. That gentle shimmer in the sky is a profound memory, a whisper from a past so distant, so ancient, that it predates everything we know. But we can go even further. With the right tools, with a keen eye and immense patience, we can peer back billions of years, almost to the very beginning of the cosmos. The deeper we look into space, the further back in time we go. It's like meticulously peeling away the intricate layers of cosmic history, one delicate photon at a time. This is precisely where telescopes transform into true time machines. Take the Hubble Space Telescope, for instance, launched in 1990 and gracefully orbiting high above Earth's obscuring atmosphere. Hubble has shown us things we never even imagined we'd see, reshaping our understanding of the universe. One of its most famous, and perhaps most humbling, achievements is the Hubble Deep Field. It was a simple, yet audacious idea. Really, astronomers pointed Hubble at what seemed like a completely empty, utterly dark patch of sky, a part so featureless and blank that it looked like absolutely nothing was there. They let it stare, patiently, 4 days on end, collecting every single faint photon, and when the images came back, that nothing had transformed into a shimmering sea of galaxies, thousands upon thousands of them, each containing billions of stars, all packed into a tiny speck of sky smaller than a single grain of sand held at arm's length. Some of those galaxies were over 13 billion years old. We were, quite literally, looking back in time, almost to the very moment when galaxies first began to form and ignite. That ancient light had traveled for nearly the entire age of the universe just to reach us. It had crossed unimaginable distances, passed by uncountable wonders, and finally, landed softly on Hubble's mirror, leaving behind a faint but permanent trace of its epic journey. Now, we possess an even more powerful time machine. The James Webb Space Telescope, launched in 2021. Webb can see even deeper into the past, probing further back in cosmic history. This is not just because it's larger, though it is, with a mirror over 6 meters wide. Crucially, It sees primarily in infrared light. That's the key. As the universe expands, light from distant galaxies is stretched, like pulling taffy, causing its wavelength to shift to longer wavelengths into the infrared spectrum. This process is called redshift, and it means that the earliest, most distant galaxies now shine mostly in infrared light. While Hubble could glimpse some of that light, Webb was meticulously built to bathe in it. Already, it's showing us galaxies that existed just a few 100 million years after the Big Bang. Some are small, irregular, and gloriously chaotic, just as we'd expect from the early stages of formation, but others are surprisingly mature, appearing like fully grown, bustling cities right after the first rudimentary huts were supposedly built. These startling discoveries are actively reshaping our understanding of how fast galaxies formed, and perhaps even rewriting parts of cosmic history. And here's the most poetic part. Perhaps a beautiful paradox. The farther away a galaxy is, the younger it truly is in reality, but the older it appears to us, because we're seeing it as it was billions of years ago, a ghostly echo from a time long past. You might think, then, that we're always looking into the past, and that's true, but it's also precisely how we learn. We can't rewind the universe, but we don't need to. It has already sent its precious memories to us, one faint photon at a time, and we are catching them, slowly, quietly, with glass and gold and immense, unwavering patience. In a profound way, this is what science often is, listening to the past with better and better ears, ever more finely tuned. Of course, all this looking back has its fundamental limits. There's a point in time we simply cannot see beyond. The cosmic microwave background, the pervasive afterglow of the Big Bang. It's not that there's nothing before it, but that the universe was opaque then, before that pivotal moment of recombination. Light simply couldn't travel freely. It was trapped, scattered, like a thick, impenetrable fog in a dense forest. Only after the universe cooled sufficiently and neutral atoms formed, did light finally break free and begin its long, uninterrupted journey to us. That's our cosmic horizon, the very edge of visibility for our telescopes, and beyond that lies mystery, infinite possibility, and profound questions we're still striving to answer. For now, what we do have is extraordinary. Every image from Webb, every frame from Hubble, is a photograph of the past, a snapshot of a moment so incredibly distant it feels like pure fiction. But it's not. It's real. That light is real. It touched something once, a star, a galaxy, a cloud of gas, and now, after eons, it touches you. So the next time you stare into the vast, beautiful night sky, remember this: you're not just looking up, you're looking back, way, way back. The stars are still shining, but many of them are shining from a time when Earth was young, when there were no eyes yet to see, no names yet to give them, and yet, their light persisted, crossing unimaginable stretches of space and time to find you here. Now, the universe doesn't just tell stories, it remembers them, holding them in its luminous embrace. We've traveled far, From the very first whispers of matter to the sprawling spirals and glowing cores of galaxies, we've witnessed the universe light up, organize, and gracefully evolve. And now, as we drift gently into the present, we find that the universe is far from finished with its grand creation. Galaxies are still forming, still merging, still reaching toward one another across the vast cosmic void. Because galaxies, much like people, tend not to live alone in isolation. Instead, they gather, they form groups, clusters, and even superclusters, massive structures so vast they defy our simple imagination. Our own Milky Way is a comfortable part of one such gathering, known as the local group. It's a relatively quiet, suburban corner of the cosmos, made up of more than 50 galaxies, most of them small and faint dwarf galaxies, orbiting the larger ones like cosmic satellites. The local group's two largest and most prominent members are, of course, US, the Milky Way, and our majestic neighbor, the Andromeda Galaxy. We are the twin giants of this little galactic suburb, slowly spiraling toward each other. We've already spoken about our future merger, but for now, the two galaxies maintain a respectful, ancient distance, close enough to notice each other's immense presence, but far enough not to bump elbows just yet. Surrounding us are a host of smaller companions. Some, like the large and small Magellanic Clouds, are easily visible from the southern hemisphere, and are themselves in the slow, inexorable process of being drawn into our mighty spiral arms. Others, like the Draco Dwarf or the Ursa Minor Dwarf, are more elusive, faint, ghostly collections of stars barely hanging on to their individual identities as they orbit through our galaxy's vast dark matter halo. Groups like ours are common across the universe, but they're just the beginning of the cosmic hierarchy. Zoom out further, and you find galaxy clusters, immense collections of hundreds or even thousands of galaxies, all bound together tightly by their mutual gravity. The Virgo cluster, for example, sits just beyond our local group, and it's densely filled with spirals, ellipticals, and every chaotic shape in between. In these crowded environments, galaxies aren't politely distant, they jostle, they crowd together, they intensely interact, and they often, quite dramatically, collide. In these bustling clusters, you can almost feel the tension, gravitational tug-of-wars happening across millions of light years. These clusters, in turn, are embedded in even grander formations, superclusters. The Laniakea supercluster, which is our cosmic address in the largest, most encompassing sense, stretches over 500 million light-years across and contains an astonishing 100,000 galaxies. That's right, 100,000 galaxies, each with billions of stars, all gently drifting together through the cosmos, meticulously following the invisible flow of gravity through an immense web we're only just beginning to map, and even that is just a single thread in the larger, overarching cosmic web, the vast, intricate structure that forms the very skeleton of the universe. Galaxies are not sprinkled randomly through space like scattered glitter. They form distinct patterns, long, intricate filaments, broad sheets, and dense, concentrated nodes, like a vast, three-dimensional foam stretched across a dark, silent sea. These structures, whose seeds were sown in the very earliest moments after the Big Bang, have been patiently shaped over billions of years by the subtle, persistent nudging of dark matter and the unrelenting pull of gravity. In between these luminous filaments lie the voids, immense, empty regions where few, if any, galaxies exist. Some are tens of millions of light-years wide, profoundly dark and silent, with only the occasional lonely galaxy drifting through, like a solitary ship at sea. It's in this striking contrast between the crowded clusters and the vast, empty voids that the grand, intricate structure of the modern universe truly reveals itself. But not everything is growing. Not everything is rushing forward with the same creative fervor. There are subtle signs that the universe's grand, creative dance may be slowing, not in motion, but in its ability to give birth to new things. Many galaxies, especially the large, mature elliptical ones, are no longer actively forming stars. They've either used up or lost the cold gas needed for stellar birth. We often call them red and dead, not because they are lifeless, but because their aging stars glow a soft, reddish light, and no vibrant new stars are replacing them. Even our own Milky Way is forming fewer stars than it once did. It's not done, not by a long shot. But the era of frantic star birth is gradually behind it. We're entering a quieter, more reflective chapter of galactic life. And the universe itself, it's expanding faster and faster, thanks to something we still don't fully understand: dark energy. This mysterious, pervasive force is pushing galaxies away from each other at accelerating speeds. Over the next few trillion years, it's possible that galaxies not gravitationally bound to us will simply vanish from our view entirely, their light stretched by the expansion until it can no longer reach us. The universe will grow colder, quieter, and more profoundly isolated. But don't worry, my friend. We've got time, a lot of time. For now, galaxies continue to interact, evolve, and constantly surprise us. With telescopes like Hubble, James Webb, and those still to come, we're peering deeper into space and further back in time than ever before. We're catching the faint echoes of galactic birth, the subtle ripples of collisions, the soft, newborn glimmer of nascent stars in galaxies so far away their light left before Earth even had oceans. Every night sky is filled with those echoes. Every glowing dot is a story, patiently waiting to be heard. Every glowing dot is a story. Some are just beginning their luminous tale, while others ended their epic long ago. But all of them are an intricate part of this vast, beautiful cosmic architecture. The visible universe is still painting itself. Even now, in this very moment. Galaxies are no longer just distant mysteries to us. They are companions, silent teachers, profound reminders that even in a universe so unimaginably large, we cannot truly hold it in our minds. We still belong to it, and in a deeply meaningful way. It belongs to us. And now, after billions of years of drifting, after traversing billions of light years of cosmic distance, we've come to the gentle end of our journey tonight. We've drifted from the very birth of the universe to the majestic birth of galaxies. From the profound cosmic dark ages to the wondrous arrival of first light, we've watched stars flare into vibrant life, cluster into luminous cities of fire, and spin gracefully through spirals shaped by invisible hands. We've seen galaxies collide, merge, slowly fade, and majestically grow old, quiet, enduring giants in a living, dynamic cosmos that never truly stands still. We've journeyed intimately through the Milky Way, our own beloved galactic home, and felt the subtle, immense pull of black holes and dark matter, the quiet, unseen architects of all that we see and perceive. And we've looked back in time, truly looked, catching ancient light that traveled across the entire universe, billions of light years, just to meet us here, now. It's truly humbling, isn't it, to know that the stars above you are not just distant points of light, but living memories, profound echoes from the cosmic past, that galaxies are not merely still images, but grand, unfolding stories, continuously written in starlight, and that everything around you, your hands, your gentle breath, the soft thoughts floating through your head, was forged in the fiery heart of a long-dead, ancient star. You are made of galaxy stuff. You are an intimate part of this grand, eternal story. And maybe, just maybe, that's why we find the night sky so incredibly comforting, why something deep inside us quiets and settles when we look up, because some ancient, primal part of us remembers what it truly feels like to drift through starlight, to be cradled by the cosmos. So now, as your eyes grow heavy, as your thoughts soften and your mind drifts, I'll ask again, just as I did when we gently began, dear traveler, where in the world are you listening from tonight? And what time is it where you are, right now, in this peaceful moment? Drop a note in the comments if you'd like. I truly love hearing where these little journeys are taking root all across our beautiful globe. It reminds me how deeply connected we are by wonder, by curiosity, and by the shared stardust from which we are all made. And if you enjoyed drifting through the cosmos with me tonight, if it brought you a moment of peace, please consider leaving a gentle like or subscribing for more sleepy science. There's a whole universe, vast and wondrous, still waiting for us to explore together. But for now, let's truly rest. Let the stars keep watch, and let the galaxies keep spinning, just as they always have, in their quiet, eternal dance. Good night, fellow traveler. Your home is truly among the stars.